All right, guys, here we go with another optimization question. I know right now you're asking yourself the question, how do I optimize more different kinds of questions, Mr. Bywater? The other question you may be asking yourself is, why the heck is he wearing that ugly wig? And I will ask you a question just like all good teachers do. And my question is, why not? Yeah, you don't have an answer, do you? Therefore, we are going to optimize with the power wig. All right, so here we go. Find the minimum surface area of a cylinder with a volume of 330 centimeters cubed. All right, now we're going to have to rack our brains and think back to geometry on this one because we will need volumes and surface areas, okay? So we're going to go ahead and start with, it asks us for the minimum surface area. And actually, you know, I have no idea what's going on here, just like usual, so I'm going to start off by drawing myself a little picture. All right? I need a picture of a cylinder. Okay, there's my cylinder, which obviously the purple is not showing up very well. In fact, you may not even be able to see that. So we'll get rid of that and we'll just redraw it in blue because we can. Now you can see it. How about that? All right, so there's my cylinder. Okay, a couple of things important to the cylinder. I'm going to have a specific height. It's going to have a certain, it's going to be tall. And then the other thing is I've got the radius. I may need a radius or diameter or something along those lines, right? Okay, so we're going to use our picture to help us answer this question. Now the first thing that we got to do is it says we need the minimum surface area. So if we need surface area, we're going to have to write an equation for surface area, all right? So it looks like I got a couple of circles here, right? That's the top and bottom of my cylinder. Well, how do I get area of a circle? Hopefully you remember the area of a circle. So this is going to be the total surface area of my cylinder. Okay, area of a circle is pi r squared. Hopefully you remember that for geometry. All right, now this is the area of one of those circles, but I got a circle on the bottom and I got a circle on the top. So I'm going to write down 2 pi r squared. Okay, and then from there I need to do the surface area of everything going around it. Now this might be a little bit hard at first, but think about one of those tin cans, you know, the cans of vegetables or fruits, canned fruits, or maybe SpaghettiOs. Yeah, you know what I'm talking about. Think about the surface area of the stuff around. Well, have you ever peeled off one of those labels or tried to peel it off? They're like stuck all over the place. But if you ever try to peel one of those off, you find out that it's just a rectangle. It's just a long rectangle that's stretched all the way around. Okay, so if it is a rectangle, this is a rectangle. You don't believe me, just take a piece of paper and wrap it around and you'll see that it creates a cylinder. Of the sides of the cylinder, the top circle and the bottom circle will be empty. But it's just a cylinder, it just goes all the way around. So this is a rectangle. So what does that rectangle look like? Well, it is this wide. That's how tall it is, right? Now we've already defined that as h. So that rectangle, for that rectangle that goes all the way around, has a height of h. Now how long is it? Well, it's got to wrap all the way around the cylinder. Well, in order for it to wrap all the way around the cylinder, then its length has to be the same as the distance around the circle. You know how to find the distance around a circle? It's circumference. And you know how to do that. It's either 2 pi r or 2d. It's completely up to you. So I'm going to write 2 pi r so that I continue to use the same variable as I had before, right? 2 times the radius, which is the diameter, and then multiply it by pi. All right, so h times 2 pi r, which means I can now put that into my formula. So I've got my 2 circles, right? And then I'm going to add on my rectangle, which is going to be 2 pi r times h. Now, wonderful. We now have our equation that we're going to want to optimize. Notice again, just like in the last 2 examples, I have 1 variable, r, 2 variables, h. So now what I need to do is I need to kind of find some way to relate r and h. Okay, I need that constraint, right, between r and h. Well, no problem. Here it is. It's coming up. We need a cylinder with a volume of 330 centimeters cubed. Well, why do I know the volume, but I don't know the surface area? Well, I'll tell you why. What if you have one of those cans of SpaghettiOs and it's supposed to hold 300 milliliters, but you want to figure out what's the best size to make your can? so that you don't have to spend as much money on coating the outside so it doesn't rust. Or you don't want to have to spend so much money on the label on the outside, so you want to minimize that surface area. Okay, I could think of a bunch of reasons why you would know a volume and need to figure out a surface area, the best way to minimize the surface area for that volume. You could make it taller, but then it would be thinner, or you can make it wider, but then it would be shorter, right? Kind of like a tuna can. Oh, I hate tuna. Ugh, that's just one of those things I cannot do. Anyway, so we need to do volume. So how do I do volume of a cylinder? Well, for a cylinder, you should have learned in geometry that I can just find the area of this circle here and then multiply it by the height. So the area of that circle, so this is going to be the volume of my cylinder, which is the area of that circle, which is 2 pi r squared. Sorry, not 2 pi r squared, just pi r squared is the area of the circle. Multiply it by the height, and that takes that circle and fills it up over that height and gives you the volume of that cylinder. So times h. And we know that that has to be equal to 330. So I'm just going to go ahead and change this to 330 equals pi r squared h. Now, at this point, you should be able to go ahead and put those variables. Remember last time what we did is we solved for one of those variables in the constraint. This is our constraint. This is what we want to optimize. So in that equation that has our constraint, we want to solve for either r or h. Which one's going to be easier? Well, I tell you, I'm going to have to substitute. If I solve for r, I got to substitute both those times with fractions, and I don't want to do that. I can just solve for h once. So I'm going to get h by itself so that I can substitute in for h. All right? So h means that I need to divide by both pi and r squared. So I'm going to divide by pi and r squared. So I now have 330 over pi r squared equals h. Now I can take that and substitute it in for h. So let's rewrite our surface area equation now. Our surface area equation is now going to look like this. It's going to be surface area equals 2 pi r squared plus 2 pi r, and then h, which is 330 over pi r squared. Just like that. Okay? Now we're almost ready to optimize. We're almost ready to take that derivative, but remember, we don't want things being multiplied like that. We want to go ahead and simplify that as much as possible so that it's easier to deal with later. All right, so I'm going to go ahead and do that. So surface area will be 2 pi r squared plus, now note that r, this one's on top, that one's on bottom, so I'll get rid of one of the r's. This is a pi on top and a pi on the bottom, so I'll get rid of that. So it'll be 2 times 330, which is 660, over the r. So now I've got my area equation. All right? Now that I've got the surface area equation, I am ready to optimize. Yes! So I'm going to do dA dr, because that's the variable. So I'm going to optimize a based off of the radius. And then I'm going to go ahead, derivative of this, 2 times 2, that would be 4 pi r. Pi is a constant, right? Pi is a constant, so we just leave it the way it is. Okay, bring the 2 in front, so it'll be 4 pi r. And then this is, remember that's 660 r to the negative 1. So I'll bring the negative 1 in front, making this negative 660. And then subtract 1, negative 1 minus 1 is negative 2. Now that I've got that, I should be able to work with my optimization. So I'm going to go dA dr equals 4 pi r minus 660 over r squared. At this point, we're ready to do that final optimization step, because remember, the optimum is when we either have a maximum or a minimum, right? In this case, we want to minimize the surface area, so we're looking for a minimum. With this, you can now go ahead and put this into a graph, okay? Or you can use NSOLVE. It's completely up to you which one you want to use, okay? But what I suggest is that we're going to go ahead and put the 0 in first, because we want the minimum or maximum, okay? So we're going to put a 0 in for the derivative. So we go 0 equals 4 pi r minus 660 over r squared. I'm going to disappear for a second. Why don't you punch that into your calculator and see what you can come up with? All right? You've got, let's say about 10 seconds. Ready? Go. All right, I'm back. Have you done it? I'll give you a couple more seconds to work that out. Okay, I'm going to go ahead and do in solve. All right, so on my calculator, I'm going to go to menu, number 3, algebra, and I'm going to choose numerical solve. And then I'm going to type in this equation. I'm going to go 0 equals, and I'm going to type 4 pi. You know, on this one, I'm going to go ahead and change it to an x, just because the x, I'm more comfortable with putting x's in. And then I'll go minus 660 over x squared. And then I'll tell it to comma x solve for x. All right, so it should look something like this. Yeah, you see that right there? In solve equals 0 equals 4 pi x minus 660 over x squared, and then comma x, solve for x. Yeah, you see that. Okay, and then I push enter, and whoa, there we go. It just gave me a number right there. It just gave me a number for that solving, and I got 3.74494. And so that means my r that I want is r equals 3.774 if we round to 3 digits. And I know you're saying, but Mr. Bauer, that's such an ugly number. I don't care, you have an ugly face. I'm just kidding, you don't have an ugly face. I think you have a wonderful face. But I want you to recognize it's okay. Numbers in the real world are not perfect, they're not lovely, they're not wonderful, they're just numbers. Deal with it. Okay? Now that I got r equals 3.74, I can go ahead, I can put that in, I can solve for h. And so I can go 330, and then I'll divide by pi, and then I'll divide by that r squared. So I'm dividing by pi, divide by r squared, that should give me h. So I'm going to divide by that 3.744. I'm going to go ahead and put in the whole number, 3.74494 squared. And then I get an h equals 7.4849 if I'm rounding to 3 digits. Okay, so now I have h, I have r, and you should be able to finish the question at that point, putting r and h in and being able to optimize a. Awesome.